Right? In today's class, we will be solving some questions uh, where we have to apply the equation of motions, right? We had a discussion on this equation of motion, right? So the basic one is V is equals to U plus AT, where V and U, you know the meaning of each variables, right? And the second one was S is equals to where S is the distance, right? U plus half a t square, where A is the acceleration and U is the initial velocity. And the third one is 2as v square minus u squared. So we are going to apply these equations, right? So the first question I'm going to share on the screen. Mm,
Do we have to memorize all of the equations?
yeah, because your syllabus is saying that you have to, make a practice of let me show the syllabus to you, right? So that you should know that this thing has to be, in your mind. See, are you able to see the syllabus? Yes.
Yeah.
So we have done this, right? Know and use the relationship between acceleration, change in velocity, and time taken, right? So we discussed this in the last class. Change in velocity divided by time, it's the acceleration. We also had a discussion around velocity time graph, right? And then we further had a discussion that how to find out the acceleration or the speed from the given graph using the gradient, right? Gradient of velocity time graph will give you acceleration. Gradient of distance time graph will give you speed, right? Okay, so and we also had a discussion that area in the velocity time graph or a distance time graph, sorry, velocity time graph will give you a distance, right? Okay, didn't we have a discussion around these? Hello.
Yeah.
So do you remember
Yeah. Hello.
we discussed, right? We discussed this. Okay. And you can see here
Yep.
1.10 says that use the relation between the final speed, initial speed, acceleration, distance, right? So you need to, keep this equation in your mind, right? Okay. V square is equals to U square plus 2as. That's the same thing that I have written here. Let me share this. Yeah. So I have written here 2as is equals to V square minus U square. Okay. Clear?
Oh
All
yeah.
right, so you can see this question. Uh, Body at rest was accelerated, or okay, it traveled for 5 minutes. Okay, the constant acceleration provided to the body was 2 meter per second square. So first of all, we can make a data so that we can identify what are the things that are given in the question. Okay. So the time the body has taken is 5 minutes. Okay, right? So do you think that we have to change this minute into second? G?
Yeah.
All right. So in order to change minute into second, what do we have to do?
Yeah. You have to
5
times
multiple
it by 60.
60. We have to multiply with 60, right? So we get 300 second.
But
Okay. And then we have acceleration provided to the body was 2 meter per second square. So the acceleration was 2 meter per second square. Can we write in this way? Yes, is it the same thing?
yeah.
Okay. Find the final velocity. They are
Yeah.
saying final velocity. We have to find out the final velocity, that is v. Okay, the object had before coming to a stop. So coming to a stop, what does this mean? Coming to a stop, that means the body finally reaches to rest, right? So that's going to be your U.
Yeah.
Okay, that's going to be your U. Okay, so U is going to be what? 0,
He was wrong.
right? Also answer the equation of motion used to find out the final velocity, right? So what we can do here, do we have any distance given in the question?
No.
No, so we can't use this one and this one, okay? Clear? So we
Yeah.
can go with this one, the first one. So V is equals to U plus AT, right? So where U is given to you that is 0, okay? And what is the value of A?
2.
Yeah, 2,
2.
okay? Right. All right. So it's 600 meter per second, right? Okay.
Yeah.
So it's literally a piece of cake, right?
Yeah.
Let's do another one. Okay, so a ball is dropped from a certain height, right? It took the ball 15 seconds to reach the ground, right? So the ball is coming, right, downward.
Yeah.
And what is the height? We have to find out the height, right? So
Yeah.
can we replace these this formula with h, right? Instead of writing s, can I write h is equals to ut plus gt squared, right? Where a has become the acceleration due to gravity, okay, and s is the distance, but over here I am taking h as a height. Is this clear now?
Yeah. Yeah.
Okay. Right. So what do we have to do now? Yes. What is the height?
So,
Height. Yes, we have to find out height, right? Okay.
yeah.
Right. Yes, carry on. You can, tell me.
It took the ball 15 seconds to reach the ground. So, we're using the second one, right? The S equals UT plus.
Right. Okay. So h is equals to ut plus half gt square. Uh, all right. Okay. So ball was initially. Also answer which equation of the motion is used to answer this
Okay.
question. Right. Okay. So we
Okay.
have to
I got it.
take the gravitational acceleration is g, right? So that is also given in the question.
Wait, T is time, right? Okay. Yeah.
All right. Acha, when the ball is, is about to leave and then it is coming down. So what is the initial velocity of the ball?
Wait, can you repeat the question?
Yeah. When the ball is, is starting to fall, right? So what should be the initial velocity?
Initial is 15.
Okay, 15 is the
Sorry.
time, right? Okay.
Sorry, yeah.
Yeah, see over here, the ball is dropped from a certain height. Do you think that the height is going to be sorry, the velocity is going to be 0? Initial velocity is going to be 0, right?
Yeah, initial is going to be 0. Yeah, that's right.
Yeah, this is what I was asking you. Okay, so we have to, write 0 over here, 0 meter per second. right? And then we have to apply the second one. S is equals to ut plus uh, half gt square, right? I can use in this way as well. So the height, that is the unknown, I can replace it with h. U is the initial velocity, time is 15 second, right? So it's going to be 0. And then half times g is 10, and then the time is 15 square, right? So your answer would be h is equals to 0 plus half times 10 times 15 times 15, right? Okay. So what should be the answer, Rita? That's going to be 2 and 5. Okay. So 15, 15, it's 225 multiplied by 5, right? So it's going to be around 11 to 5 meters, right? Got it?
Yeah. So in this equation, you don't require final velocity, right?
If they are asking, then we can, if they say that to find out the final velocity, with what velocity does the ball hit the ground, then we have to, right?
Yeah.
There. Okay, so let's take another one. Okay, so do you have any idea about the instantaneous velocity? Although this is not the part of the syllabus, but if I say that instantaneous velocity, what is instantaneous velocity?
No, I don't know.
Okay, instant. By the word instant, what do you understand?
Uh,
It's a very
right.
smallest time, right?
Yeah.
For the short interval of time, right? So when I say the average velocity is almost equal to the instantaneous velocity. So what
No,
does it?
no, which the final velocity?
No, average velocity
Oh,
is equal to instantaneous velocity. So what do you understand from this statement?
uh, the average. That means the average velocity was the same as the 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 velocity of a short period of time.
Short period of time. Okay. So by the word instantaneous, you take that there's a very short interval of time, right?
Yeah.
So average velocity is, is always taken when the body is moving with a different speed, right? For the uniform motion, for the body which is moving with with different speed, so we consider the average speed for our, conveniency. Okay, for our convenient, we take the average speed when we know the total distance and the total time, right? So if the total distance and total time is given to us, and then we take the average speed, number one. And if average speed becomes equal to the instantaneous speed, right? So that means that throughout the motion there is no variation in the speed. Yes, are you getting my point?
Yeah, yeah. So
Okay,
it was
so you just need to write the answer in this way: the average speed, average velocity. Okay, average, since they are using the word average velocity here. Okay, so average velocity when equals to instantaneous velocity means there is there is no variation in the motion, right?
yeah,
It is almost moving with constant speed, right?
yeah,
Yeah.
yeah.
All right. So, all right, see this one. A car is okay. A car with an initial speed of 1 meter per second was in motion for 10 minutes, right?
Yeah.
With an initial speed. So the initial speed that is discussed here and was in a motion for 10 minutes. So the time is
Time.
given. We have to convert into seconds, right? And then it came to stop. That means the final velocity is discussed here, right? The velocity right before it stopped was 5 meter per second. That is also given here. What was the constant acceleration? Okay, so we have to find out acceleration here. So is it a piece of cake again, right? So we can apply the same formula, equation of motion. U that is 1 meter per second, right? And the time that is taken by the body to reach to 5 meter per second, it's going to be 600 seconds, right? Are you getting this?
Yeah, yeah.
And finally, the body reaches to 5 meter per second, and we have to find out the acceleration. Okay, so we can use the equation of motion. V is equals to U plus AT, right? And now we can modify it. Okay, so we can shift this U to the left side. V minus U is equals to AT.
So v minus
And
v over t is it?
yeah, exactly. So it's going to be V minus U divided by T is going to be 8. You just need to plug the values and you get the answer, okay?
Yeah.
So tell me the answer. What is the final answer?
So it will be so at the start will be 5 minus 1 divided by 600.
Hmm,
So it will be 4 divided by 600, which will be uh 1 over 150.
right, okay. So 1 over 150 means what should be
So
in
so
in decimal. It's around zero
I
point
don't know. I'll check.
zero zero. Okay, 1.0, sorry, 0.006. Okay, meter per second square.
Yeah. In the exam, are we supposed to write in decimal or fraction? If it
We have to write in a decimal form, right?
so 0.066 meters per second square.
Now see this one.
Yeah. Okay.
Okay, first of all, make a data, right?
Yeah.
And then you can easily, find out the way. What do we have to find out? Okay. So I'm giving you 30 seconds to think about this.
Should I answer in the 30 seconds?
You can answer in a chat box as well, or you can share the final answer as well. Okay. Yes. Have you found the answer?
Oh, wait, can you give me one sec?
Okay, all right.
Okay. I got an idea.
Okay.
Uh, volume. Okay. So since they've given the initial velocity
Hmm.
and the distance and the time,
Hmm.
I used the second question s equals ut
Hmm.
plus 1/2 at squared.
Yeah.
So now I have found out. So right now I found out 2000, which is you convert 2 kilometers into meters, which is 2000,
Yeah.
and then yeah, and then so the initial speed times sorry, initial velocity times the minutes, seconds, which are 480 seconds, so 1 times 480, and then I got plus 1/2 times a times 480 squared.
Yeah. Okay. So am I doing the same way? Right?
Yeah, yeah,
Okay. So we are going to subtract the 480 uh from 2000, right? Okay.
yeah. So 1520 equal.
Yeah. 2000 minus 480. Is it 1520, right? Okay.
Yeah,
So if I divide this 2,230,400 by 2, so what will I get? It's it's 115 and 200, right? Okay, so this is in product, so I need to shift it in the denominator side, so it will become this thing, right? Okay,
yeah.
so the finally I'm getting 1520 divided by 115200, right? So
I
it's going to be around 0.013, right? Meter per second is squared.
yeah, I got the same answer but in a different way.
Okay, right. So that's going to be uh 0.013. Okay. All right. I hope that you have got the idea that how are we going to apply, right? So now after that, we are going to discuss describe the effects of forces between bodies such as changes in speed, shape, or direction, right? So this is our LO, the from forces, movement, shape, and momentum. Okay. All right. So describe the effect of forces between bodies such as change in speed, shape, or a direction, right? So do you think that we had already touched upon these things, right?
Yeah.
All right. So um forces, I think I have already touched on forces, right? So
Mm.
forces can be push or pull, right? And it's the agent that no that changes the state of a body, right?
Yeah.
So effect of forces could be effect of forces uh could be what? Effect of forces could be
Uh,
effect of forces
change of
change, yeah, change of shape, right?
speed,
Change of shape हो सकता है, yes, it can be.
speed, shape, direction.
Yeah, direction, because if object is moving, right, and you want to, change the direction, so you need to apply unbalanced force, right? You need to apply unbalanced force, okay, to bring the change, to bring the change in the to bring the change in the direction of motion. So yes, change in direction. Acha, yes, if any object is moving with the, let's say, if any speed, right? If the object is moving with the 50 kilometer per hour, right? Okay. Now, if I want to increase the speed, so what do I have to do? I have to apply a greater force, right? Greater unbalanced force, right? So greater unbalanced force to speed up, right? To speed up the body, right? So, what if I apply a balanced force? Do you think will it give any impact on the body?
No.
No. So we have to have the unbalanced force in order to, speed up the body. So yes, change in speed, right? So we have already discussed in the, Newton's laws, right, of motion. When we want to accelerate the body, if the force is applied on the body, the acceleration is produced, as which is directly proportional to the magnitude of the force, and is always in the direction of the force, right? Okay. All right. So after that, we have the identify different types of forces such as gravitational or electrostatic force. So yes, there are many types of forces, right, that exist. So in the next class, we'll be, discussing in detail the types of forces, right? So when we talk about the different types of forces, right? So forces can be, first of all, types of forces. When we talk about types of forces, so it could be mm, types of forces, contact, contact force, and non-contact force. Okay. Are you getting my point? Why am I, categorizing the types of
Yeah.
forces? Because there are other, forces that are in contact, but in our syllabus, they are just talking about the gravitational force and the electrostatic force, right? So yes, non-contact force like magnetic force, okay, magnetic force,
Gravity.
yeah, gravitational force, gravitational force,
Upthrust.
electrostatic force, okay. Static force, right? Non-contact, do you have any idea about the non-contact force? Could be air resistance. Sorry, not contact force. I'm talking about contact force. Air resistance.
Water resistance.
It could be friction. Yes. Um, so if you find other type of contact force, so you can write in this way, you can include it. Okay, so we inshallah in the next class we will be discussing the gravitational force and the electrostatic force in detail. Gravitational force due to the masses or any object which has mass, so they will have the force of gravity, and it's going to give impact on other object, right? Electrostatic force, it is related to the charges, right? When two objects are charged bodies, right? So they are going to have the repulsive force or the attractive force, okay? Gravitational force is always attractive force, remember, okay? And electrostatic force can be attractive or can be repulsive, right? So inshallah, we'll be discussing these two forces in the next class. So that will cover our LO. So let me share the screen so that how much we have covered from our syllabus. See, we are here, okay? So they identified different types of force such as gravitational or electrostatic force. Okay. So they have talked about the gravitational or electrostatic. And yes, if in the past paper, if they have asked other type of forces, then definitely we are going to discuss. Okay. Right.
Okay.
Okay. So take care. Allah Hafiz. Assalamu alaikum.
Fine.